So now we have a condition here. All polynomial functions, they are continuous. It's very simple to understand. Polynomial functions, they are always continuous. And also if f and g, we are having two different functions. F is one function and g is another function. If both of them are continuous function, that means f is also continuous and g is also continuous, then we have these kind of cases here. F plus g, we are adding both the functions together, and when we do that, it will be continuous at any point x equal c. And f minus g will also be continuous at any point. F into g, it also will be continuous at any point. And f by g, that means we are dividing it, the first function by the second one. And here we are having a restriction g of c. That means the below function, it should not be equal to 0. If this is satisfied, then it is continuous at every point x is equal to c. So when we do any kind of operation for two continuous functions, the operation, it will be continuous itself at any point. And for the only division, we have a restriction g of c, it should not be equal to 0. Next, we have a question here. We have to prove that every rational function is continuous. So first of all, to represent any rational function, we'll be using it like this, p by q form, right? P by q form is a rational number. So p and q both are like a polynomial function, and we know that for a rational number, q, it should not be equal to 0, right? Q, it should not be equal to 0, and any rational number can be written in the form p by q, and where p is a polynomial function and q is also a polynomial function, right? So this is the representation for a rational number, and we know that any polynomial function, it will be continuous. All polynomial functions are continuous. So if you see that p will also be continuous and q also will be continuous, and we also have a restriction here, q, it should not be equal to 0. So as the numerator and denominator both are continuous and it is not equal to 0, the denominator is not equal to 0, therefore we can say that the rational numbers are continuous at all points. So now we have another question here. We have to check the continuity of the function sine of x. So first of all, to check the continuity, what we have to do means we have to find the limit of x tends to 0 and sine of x, right? So what we will be doing here means, instead of x, we'll be writing it as limit sine x plus h, because we have to check the continuity at 0 only, right? Because it's changing from negative to positive. So in this case, we have to check at the point 0 only. So first of all, for solving this question, we'll be taking the limit of sine. Instead of x, we'll be putting it as x plus h, where h actually tends to 0. Let's assume h is almost equal to 0, because x plus 0, it will be equal to x itself, right? So that's why we are doing this kind of adding here. So we know that sine, when it is added with anything, we can write it like this: sine of x times cos of h plus sine of h times cos of x. So this is a condition here. So when we are doing this, so it will be limit of h tends to 0, sine x cos h plus sine h and cos x. So now we can take the limit inside, because limit you can separate it for addition, subtraction, anything. So first one, when we are taking the limit, right? So it will be sine x. We don't have a limit for x, we have a limit for h only. So it will be cos 0 plus sine h. So it will be sine 0 instead of h it will be 0, and cos x, we don't have a limit for x. So when we do this, cos of 0 is 1, whereas sine of 0 is 0. So this whole part will be equal to 0 itself, whereas this part will be sine x into 1, so it will be sine x. So finally we'll be arriving at sine x as the answer. So when you check our f of c, it is actually equal to sine x only, right? So when we are taking the limit h tends to 0 sine of x plus h, we are arriving at the final answer as sine x. So as both of them are equal, because we arrived at the result, finally we can say that sine x, it's continuous at all points. We are having one more question here, f of x. This function, it is equal to x square minus 25 over x plus 5, and x is not equal to minus 5. So if you check the numerator part, it can be written of this form, a square minus b square, right? And this one, when you expand it, it will be equal to a plus b into a minus b. This is an identity. So instead of a squared, we are having x squared, and then instead of b squared, we are having 25. So when you see our a, it will be equal to x, and our b, it will be equal to 5, because 5 squared is 25, right? So according to this equation, we can expand the numerator here also. Instead of a plus b, we can put it as a is our x plus b is our 5, and then instead of a minus b, it will be x minus 5. So denominator is x plus 5. So you can see that the denominator and the numerator, one of the terms could be cancelled out, x plus 5 and x plus 5. So finally we'll be arriving at this simplified answer. Our f of x, it is equal to x minus 5. So if you see, this is a polynomial function, right? So as it is a polynomial function, we know that every polynomial functions are continuous at every point. So we can say that the given function, this one also, it is continuous at every point.